Hey there, let's discuss a problem from mechanics today, and let's read the problem. Two particles are there, P and Q, of masses 2m kilograms and m kilogram respectively, are held at rest in the same vertical line. The heights of P and Q above horizontal ground are 1 meter and 2 meter respectively. The particle P is projected vertically upwards with a speed 2 meter per second. At the same instant, Q is released from the rest. So from this problem, we can draw a diagram. Let this be the ground, and the two particles P and Q at a vertical line. Okay, so one particle is here, there, and the other particle is at here. So the one which is closer to the ground is the P, because it is only 1 meter above the horizontal ground. So this would be P, and the distance from the ground is 1 meter. So the one at the higher position is Q, and it is having a mass of 2m kilograms, and P have a mass of m kilograms, and Q is at a height of 2 meters from the horizontal ground. Now in the question they are telling us that the Q is released downwards and P is projected upwards. Since Q is at a higher position and it is releasing, it will come down then with the influence of gravity. But that's not the case with P. P is projected upwards with a velocity of 2 meter per second. So this is the case. And the first part of question, they are asking us to find the speed of each particle immediately before they collide. So we need to find the velocities of these particles during the time of collision, just before collision. So we need to define the equations of motion, and let's set the ground as height h equal to 0, and let's take the upward direction as positive. So any measurement that we take along the upward direction can be considered to be positive. So here, regarding the acceleration A, we can consider it as minus g, and we can approximate it to 10 meter per second for simplicity square for both the particles. Now let's try to solve this problem for each particle. So let's take the first particle P. So for P, its mass is 2m kilograms. So I'm writing it as 2m, and its initial height from the ground is not 0, it's about 1 meters from the ground, and the initial velocity with which it is getting projected is 2 meter per second. So these are the information they have already provided in the problem. Now we are going to find the position at time t. So we are trying to find the position of P with respect to time as a function of time. Let's call it as Sp of t, where the suffix P stands for this distance corresponds to the particle P. We can write it like 1 plus ut plus half at square, where 1 is the initial height, that which we have already written here. So it is at an initial height, so we are adding it to the distance that it covers with respect to time. So substituting the values that we already have, we will get something like 1 plus u is to 2t. Then substituting for a, it's minus 10. So minus 10 by 2t square, or it will become 1 plus 2t minus 5t square. So the final expression would be like 1 plus 2t minus 5t square. Let's call it as equation number 1. Now for this particle, we can find an expression for the velocity with respect to time as a function of time. So the velocity at a time t, let's call it as Vp of t is equal to, let's use the expression v equals to u plus at. Here there is an initial velocity, we do have acceleration, then substituting the value for u, it's 2, then plus, for acceleration it's minus 10, then t, which gives a final expression 2 minus 10t. So let it be equation number 2. Okay, let me highlight these equations. Now we are done with the particle P. Now let's move to the particle Q. So for particle Q, its mass is equal to m, and its initial height is equal to 2 meters. Don't get confused with the m, that which we used with the mass. For height, m stands for the meter, its unit. It's 2 meters. And the initial velocity, regarding the initial velocity, let it be uq, which is equal to 0. We know it is at rest. So similar to what we have done in the case of particle P, let's find the expression for position as a function of time. So position at time t, let it be sq of t. This is regarding the particle q, so we are giving the suffix q. Similar to what we have done in the previous case, instead of writing 1, let's write 2 plus ut plus half at square, ut plus half at square. Substituting, we know that u is equal to 0. Therefore the expression will become 2 minus 5t square after simplification. And let's consider this as equation number 3, 2 minus 5t square. And again the velocity at a time t, which is vq of t, is equal to the expression is v is equal to u plus at. Here u is equal to 0, therefore 0 minus 10t, which is equal to minus 10t. Let it be expression number 4. Now we have 4 expressions. Our next objective is to find the expression for the not to find the expression, but to find the exact value of the velocity during the time of its collision. But note that the logic that we are trying to use here to find this expression is, with respect to the ground, the particle q is at a height of 2 meters, isn't it? So particle P is at a height of 1 meter. Now when q is released and P is projected upwards, so both of them will reach at a specific point during the collision or just before the collision. Okay, so let it be this point. So both of them are colliding at each other, and we need to find the velocity at this particular point. So both of them are meeting at a distance s from the ground. So during the time of collision, this distance will remain same. So we can write it down here. During the time of collision, the height of P and Q will be same. So we have already found out the expression for these heights, so we can equate it. So during the time of collision, so let's use the equations using the equation number 1 and 3. Equation number 1 is 1 plus 2t minus 5t square is equal to 2 minus 5t square. Let's cancel the 5t square terms. Then rest of the terms are 1 plus 2t is equal to 2, or 2t is equal to 2 minus 1, or t is equal to half, which is equal to 0.5 seconds. So this 0.5 seconds is the time after which both of these particles will collide. So P and Q collides after 0.5 seconds. So we got the time period required for these particles to get collided. Also we derived an expression to find the velocity with respect to time. So substituting this t equal to 0.5 seconds into the expression for velocity, we are going to substitute this value. So for the particle P, the expression was, see the second equation, 2 minus 10t. So V of P with respect to time is equal to 2 minus 10t. So putting t is equal to 0.5 seconds, we will get 2 minus 10 into 0.5, which is equal to 2 minus 5, which is equal to minus 3 meter per second. This is the expression for velocity. Let's find the expression for speed. Since speed is equal to magnitude of velocity, we can write the value of speed as 3 meter per second. Similarly, considering the case of particle Q, VQ of t can be written like, it's the expression for, it is minus 10t, which is equal to minus 10 into 0.5, which is equal to minus 5 meter per second. Or again, we can find the speed is equal to the magnitude of minus 5, which is equal to 5 meter per second. So we got the final answer, 3 meter per second and 5 meter per second. This is the expression for the velocity, or these are the velocities during the time just before the collision. So this is how we solve this problem.